Right, question 12b, you're presented with this graph and it tells us that we've got two forces, A and B, and they act through the same point in an object. It tells us that the same point, so the object won't be rotating, there's no moment. These two forces are shown in figure 12.1 and no other forces are acting on the object. Right, so we're presented with this graph and first thing we need to do is look at what the axes are. So it's telling us that along the bottom axis here we've got the x component of the force, and then on here we've got the vertical axis, we've got the y component of the force. So we can see we've got force A that has got an x component and a y component, and we've got force B that has got an x component and a y component. And part I is asking us to determine the x and the y component of force B. Well, this really is just a case of coming along and reading off the graph. So force B, I can see if I follow that down, that has got an x component of 6.0 newtons, checking the units are correct, and if I come along here I can see that my y component is 2.0 newtons. And that's part one done simply enough. Let's move on to part two, which is now saying use the figure to determine the magnitude of the resultant of these two forces A and B. So the magnitude of the resultant force is when we add these two forces together. So if we come back to the graph, what we can see is we've got forces A and B and we want to add these two forces together. When you add forces, what you need to do is draw them out tip to tail, so we can still use this graph, which is why it's given you all of this extra space to play around with. Well, we know that B has got an x component of 6 and a y component of 2, and force A, if we look, it has got a x component of 2 and a y component of 3. So if I was to come along and draw these two vectors out tip to tail, so it doesn't matter which one you choose, but I'm going to choose to draw A added onto B. So A has got an x component of 2 and a y component of 3. So what that would mean is I would need to come along an extra 2, taking me to 8 newtons of the x, and then add on another 3, which would bring me up to 5. So let's see how well I can draw it on this graph. So it would take me, I think, to that point there. And now I've added the two vectors together. And what I need to now realise is my resultant vector. I'll do that in a different colour. Let's go for blue. So my resultant vector would be equivalent to that. So let's call that the resultant. And now what I need to realise is, if I stay in my blue, that my resultant vector I can split into components. It has an x component of 8 and it has a y component of 5. So 8 and 5, and because these components are at right angles to each other, I form myself a right angle triangle. So I need to find the magnitude of r, so if I use Pythagoras' theorem, I can go back into this and I could say that r, let's go back to a pen, r is going to equal, r squared is going to equal the x component squared plus the y component squared, so r will equal the square root of x squared plus y squared, and substitute my values in. R is going to equal the square root of 8 squared plus 5 squared, which equals the square root of 64 plus 25. Just quickly get my calculator, which is 89. So that's the square root of 89, which comes out as being 9.4 newtons.